guys. Holy smokes, I'm sorry about that. That was ridiculous. Okay. Okay. Hey, guys, we're going to start here today. Pretty easy section, honestly. And I think the point that I want to make today is that everything that we're doing today is still linear. Everything today we're looking at is still linear. So you want to have your journals there to page 106, and we'll get running with this today, guys. 4.4 is entitled Scatter Plots and Lines of Fit. And what we're asking ourselves is how can you use a scatter plot and a line of fit to make conclusions about data? I'm going to volunteer to read my definition of scatter plot right there for me first. Volunteer to read that. Go ahead, Tori.
A scatter plot is a graph that shows those between two data sets. The two data sets are graphed in ordered pairs.
Okay, so down here they're comparing a husband's age to a wife's age. Okay, so it says in the exploration right here, it says finding a line of fit. We have the points in there already, but it says a survey was taken out of how many married couples here? 179 couples, and each person was asked his or her age. And it says the scatter plot shows the results. So as an example right here, kiddos. Great, this is not going to work now. Jeez Louise. When it rains, it pours. Technology at Union High School. Yes, I want to be recorded. Technology at Union High School stinks. Okay, let me say it one more time. Technology at Union High School stinks. Anybody wants to know how I really feel? Technology stinks. All right, so guys, what I want to get at here today is following. I want to show you what I'm talking about here and how this is going to work. As an example right here, kiddos, this is what is really being said. If you look at these points here with me, what's really going on, something like this is a bond. Right? If I say I circle this point right there, that one right there, according to that point that I circled right up there, what's the husband's age right there, guys? Somewhere between 50 and 55. So 53 would be a good example here. And how old is this particular husband's wife according to this chart? 63. Okay, 63. So she might have had a lot of money. Maybe he went after her because she had a lot of money. I don't know. All right. But this kind of shows all the couples' ages. Now, guys, most people when they get married are typically around the same age. Not all the time. Not all the time. But in this particular example, they show the ages of the husband and the wife. So we're comparing two sets of data. How many dots are going to be on that graph right there, kiddos? 179. Okay, so part A says this. Draw a line that approximates the data and then write an equation of the line. Explain the method we use. Here's the deal. When you have scatter plots like this, you're looking for something that might show some kind of a correlation. Typically here, guys, if you look at this graph right here, what would you say? You fill in the blank, I guess is what I'm getting at. If I say, as a husband's age increases in marriage, what's also true about the wife's age? It is also increasing. So as I move further right, it looks like these values are moving further up. All right? So the first thing they ask you to do, and they want you to do this here, is this. When you have data like this, do you guys agree that this data kind of tends to be around a line like this right here? Would you guys agree that that's an okay line to draw right there? Okay, so here's what I want you to do. With your ruler, go ahead, just sketch a line in there like I have, kind of as close to the data. That's what it means to put in a fitted line to the data. Okay, we're going to put in a fitted line to the data. And what we're going to do is we're going to come up with an equation for that fitted line to allow us to make predictions about a wife's age as we know a husband's age. Okay, so just go ahead and draw a line. Doesn't have to be perfect. Something similar to what I've got there would be good. Okay. Have you guys got that line drawn in there, number one? This is called a line of best fit or a fitted line, if you will. Okay? Right up here it says finding a line of fit. Okay. So the next thing they ask us to do is to write an equation of the line. So here's what I'm going to do, guys. I'm going to pick a couple points right here. On this graph, tell me I hit a corner box somewhere. I'll kind of cheat this a bit. Give me a second. All right, I'm going to choose some points right about here. All right, I'm going to kind of circle right about here. Here's a point that I'm going to highlight, and maybe a point right up here that I'm going to highlight. Now, you might want to highlight the same ones that I have because your line is going to be fairly close to that. So the first point that I highlighted is 45, 45. You might want to do the same thing. And then the other line I highlighted here was right 65 and up 65. So I'm going to put these down, 65, 65, and 45, 45. All right, here's the deal on this, guys. If you want to write an equation for this right here, what do you have to always find first? Slope. Okay, find the slope. All right. So in this right here, based on the line that we've drawn, I'm going to go ahead and find that slope. So I'm going to find my rise and my run. So guys, go from age 45 on a woman's age. I'm sorry, from 45 up to 65 on the y's. What's the change in y? What's 65 minus 45 here, kiddos? 20. So my rise is 20. How about your run when you do, whoops. How about your run when you do, 65 minus 45 right there? 20 as well. So guys, you agree the slope is 20 over 20? What value is that? 1. Slope's 1. Okay, slope's 1. So to write an equation in point slope form, I'm going to use this one right down here, 45, 45 as my point. So I'm going to go y minus 45 equals 1 times x minus 45. Y minus 45, whoops, I messed that up. Y minus 45 So you guys get that the first thing I did is found my slope, right? And that's all stuff we've done in the past. Would you agree? You guys agree with that? And then for point slope form, I went y minus 45. I'm choosing to use this point right here. Okay. Anybody punch that out and get an answer for me yet? Y equals 1x, you bet. Okay, so you're done with this, y is equal to 1x. That's the equation we're going to come up with here. Okay. Now guys, what does y represent again, right here? What does the y value represent? The wife's age. What's the x value represent? The husband's age. So I'm going to make sure, first of all, this is going to go away here in a second. Do you guys have this stuff written down in your notes, first of all? Anybody need more time? Getting that down? Okay, so let me clean this up here. I'll scroll on down a little bit. So up top here in this equation right here, you have y is equal to x, don't you? So the question becomes right here, what conclusions can you make from the equation you wrote? What does this y equal x mean, and what does it mean in the context of the problem? In other words, what could you say according to those points? Well, what did y represent again? Wife's age is equal to the x value, which is the what? So based on this right here, we would say, hey, in this example, the husband and the wife are about the same age. Is that true for all the points? No, because we looked at the example right off the bat that had a point where the wife was 10 years older than the husband. Not always exact, but for the most part, most of those points are in a situation where the husband's age is about equal to the wife's age. Now, just as an example, yesterday when second hour did this lesson, they found out the line that we drew in that class that the wife's age was on average about 3 to 4 years younger than the husband. So it can differ depending on where you draw your line. So what conclusion would we make from this? Well, husband's age. I'm going to say the husband and the wife are about about the same age. Husband and a wife are about the same age right here, okay? So that's what you want to say. That the husband and the wife in that example are about the same age. Husband and the wife are about the same age. So questions on that first page below. You understand how I drew a line of fit in there? Once I got that line of fit in there, do you understand how I came up with an equation for that line of fit? What do we have to find first? Slope, and then use a point in point slope form and write your equation. Once you have your equation, then you can start answering some questions. Okay, so let's take a look here. Let's take a look here. Example 2. Take a look at example 2. I like example 2. This is a good one. All right, so in example 2 right here, what you need, Andrew? What's that?
I need help on the quiz.
I'm going to be a little bit right now, so it might be 20, 25 minutes. Yep. Sound good? Okay. All right, guys, the scatter plot below shows the median ages of American women at their first marriage for selected years from 1960 through 2010. So guys, in 1960, middle-aged woman, what was about the middle age that a woman was getting married in 1960? What's this say right about here? About 20, actually, isn't it? Because 21 will be right in the middle of 20 and 22, wouldn't it? So right about 20, okay? Fast forward to the year 2010. About how old are girls now getting married in 2010? So it looks like as time is going on, what's happening to that median marriage age for women? It's growing. What are some reasons that it might be getting older? Girls are going to school, getting educated. Yeah, you bet. In 1960, were there a lot of girls in college? Not really. 2010, are there a lot of girls in college now? There are a lot of them. Okay, so that might be a reason. So here's what we're going to do. I want to talk about part A here, and I want to make sure we really understand what's going on here. It says draw a line that approximates the data. We want to write an equation of the line that we drew. This last sentence is very important, or next one I should say. It says let x represent the number of what? Number of years since when? 1960. So this is something like this. When it's worded like this, you want that 1960 be your starting time. So what I want you to put right below 1960 is this value. Put this value of 0 down here. Okay? In 1960, this is when it started. So times 0 right there, okay? What's that make 1970? How many years past 60 is 70? 10 years. So here you're going to put a 10. 80 would be what? What would 80 be? 90 would be 30. 2000 would be 40. How about 2010? 50. Okay. Guys, I'm going to use the endpoints to draw my line of fit. So I'll have you do the same thing here. So let's do that. Draw a line from the endpoints here to this endpoint. Fix this here quickly. Okay, I think that would be the best thing for you to do. Just connect the very end points right there. So far left and far right. Guys, when I draw my line, are those points pretty well set on the line, or pretty darn close to the fitted line? Are we okay with that? We are, aren't we? Okay. So we have to write an equation for that. So again, we know how to do this. I use the point on the very end. Now, I'm not going to call this point on the far left 1960 comma 20, but rather we're going to call it what comma 20? 0 comma 20. This is the point 0 comma 20. Oh, by the way, guys, this goes back to the very beginning of the chapter. If you have a 0 comma something, what's that make your 20? Y-intercept. Very good. What point do I have over here on the far right then, guys? About what was that last age over here? 26 at 50 years. 50 years past 1960 would be 2010. So I'm going to call this point 50 comma 26. All right, nice thing here is we already know the y-intercept, don't we? Already know the y-intercept. So help me with my equation, guys. The first thing I would need to find is I've always said this, the first thing we're always finding is the slope again. So Kayla, you want to help me with this right here? rise over run, so I'll go from here up to here. How far do I rise from 20 up to 26? 6 units. So my rise is 6. How about my run distance? 0 up to 50? 50. So wouldn't the slope in this right here be 6 divided by 50? Oh, ooh, that's a funny look at 50. Do you get that that's 50? I like it. I like it. 6 divided by 50, what is that? 0.12. So the slope is 0.12. And now what was the y-intercept, kiddos? 20. Okay, everybody understand how I got that there?
Yes.
Okay, so what conclusions can you make from this right here? Well, guys, what kind of a slope do we have here? Positive or what? Negative. So as time continues to go on, what's happening to the median age for women's marriage? It's increasing. Okay, so I'm going to say, as time goes on, okay, women are getting married at an older age. Not saying that they're ancient, just saying that it's a little bit older. Okay. Okay. As time goes on, women are getting married at an older age. We already talked about some of the reasons. Some of the reasons were, they're going to college now, or they're getting set in their ways, or maybe they just don't want to get married. I don't know. Okay. Finally, part C says the following. Use the equation that you wrote in part A for the median age of American women at their first marriage in the year of 2020. Okay. So we want to know how old women are going to be. What's the middle age going to be for girls in the year 2020? How old will you guys be in 2020? 20? 20 and 2020. That's a lot of fun. Maybe if you buy 20 lottery tickets when you turn 20. Might have $20 million. What's that? Really? That'd be cool. That's my vision, 2020. I've been making fun of my glasses already today. I told I look like a nerd once. It's not funny.
You're gonna wear glasses too.
All right, write your equation here, guys. How many years past 1960 is 2020? How many years past 1960 is 2020? 60 years. So to find this right here, we need to let x equal what value, guys? What was that value again, Nolan? 60. So do that. Plug 60 in for x right here. Plug 60 in for x. Go 0.12 times 60. And then add 20 to that value. Tell me what you got. 27.2. So in 2020, the median age will be 27.2 years old. Okay. Couple questions. First of all, if I gave you a data set, can you fit a line to that data, number one? Once you've got that line fitted to that data, can you come up with an equation for that line? Secondly, once you've got that equation, can you answer some questions related to the equation that you drew for the data of that fitted line? That's what's going on, okay? All right. Just about done here today. Everybody have that stuff down because it's going to disappear here real quickly. Everybody got what they need? Xavier, let me know when you've got her. Great. All right. jump ahead to the note-taking part right here. Guys, right here is where I'm at. All right, kiddos, here we go. This is an important concept right here. A lot of your questions that you're going to get asked in the assignment today are going to deal with this right here. But page 108, I should say. On page 108, you say you have a scatter plot. And up in this here for core concept, it says a scatter plot is a graph that shows a relationship between two data sets. The two data sets are graphed as ordered pairs in a coordinate plane. Scatter plots can show. They ever say, does it show a trend? What trend is shown right here? Here's how you're going to answer this, right? I want you to make 3 first quadrant graphs like this, right down here. 3 first quadrant graphs. Okay. Guys, like in the example when we were comparing a husband's age to a wife's age, as the husband's age got older, what was happening to the wife's age? So as I look at this right here, I might have a graph that can move uphill like this. Okay? All right, so as my x increases right here, what happens to your y values? They're increasing, okay? We say this right here, if I drew a fitted line to this right here, guys, would that fitted line be uphill or downhill? Uphill, is that going to represent a positive or a negative slope? So anytime you draw a fitted line in something and it shows some kind of a positive slope, you're going to say this is going to show a positive correlation. So if a question says, what kind of trend do you see in this right here? You say we have a positive correlation, okay? Here's an example. Here's an example. As a kid growing up, the older I got, what happened to my height? I got taller and taller. Okay? Now, right now, am I getting any taller? At some point, I'm going to start doing what? Shrinking. Okay? Well, if this is a positive correlation, what do you expect to be here? What kind of correlation is that with all those dots? This would be negative. Okay, an example in real life of a negative correlation. Here it is. As I get older, what happens to the amount of hair on my head? It starts going away. The amount of hair I have lessens the older I get. Okay? All right, so that would be a negative correlation. Then you have stuff that looks just like this. You got stuff everywhere. This guy looks like Hurricane Patricia. Really? I don't really know what kind of line I could draw in here. I don't know if I could draw a positive correlation, a negative correlation, a horizontal line, but there's really no uphill or downhill or flat line in this right here. So is there any correlation here? No, absolutely no correlation. An example of something might be like this. People with green eyes in their shoe sizes. Number of people with green eyes in their shoe sizes. You think there's going to be a lot of people with green eyes with different shoe sizes? Okay. So it could be babies, could be Shaquille O'Neal. I just don't know. All right. Okay, so if they ever ask you about trends, your 3 options are what? Positive,
negative, no.
no correlation. So let's jump ahead here. Let's jump ahead. I'm going to skip page. We're going to skip page 109. Don't really need to do that. How about page 110? This is where I'm at. Last thing we'll look at here. It says in exercises 2, tell whether x and y show a positive, a negative, or no correlation. So take a look at your scatter plot in box or example 2 here. What do you have? Positive, negative, or no correlation? What kind of correlation on these dots? Positive here. Okay, it's increasing. How about these? Could I draw a fitted line like this right in here? Good, couldn't I? What kind of correlation or trend does this show? Negative. How about this one? This one's kind of all over the place, isn't it? So this would be no correlation. And then finally, number 5. How about your last one right here? Number 5. So positive. Okay. How do you guys feel about this?
So good.
Pretty good, right? Really, the big idea today is this. If you've got a set of data, get a fitted line drawn in there. Once you've got your fitted line there, choose a couple of points to come up with your equation. Okay? Point slope form, in other words. We've been doing that a lot. That should be like the back of our hand easy right now. Then, once you've got that equation, use that to answer some information. Once the information's taken care of there, you need to identify some type of a trend. Right? I sent an assignment out over this, so you should have that. That won't be due until Monday. Don't forget about the stuff that's due by 4 o'clock today. I do have a short quick quiz. The quick quiz is going to kind of take some time. It's got to plot a bunch of points and then use that for correlation. Okay? And the quick quiz is going to be kind of like a puzzle. So here's what I'm going to hand out to you guys. Start recording here first of all. So give me a second.